We've done adding, subtracting, now we're doing multiplying fractions. They're very much straightforward. Okay, so you don't have to stress too much. They're a lot easier, in my opinion, than doing adding, subtracting. Okay, you don't necessarily need to convert all of them to the same base, so that's not needed. Alright, so we've got 2 on 5 of 15, so you might get like a word question. How much is, a third of this number? Or how much is 2/5 of this number? The easy translation of that is basically when you've got this thing here translates into a multiplication sign. 2/5 of a 15, so that's going to give me 2 on the 5, and that 15 ends up hanging out on top of the fraction. That's how it translates. So I'm going to be asking you guys, what is 2 times 15? Because I'm not able to do that maths in my head. 30. 30 on 5 is my answer. Can it be any nicer than that?
6.
Thanks. Easy. Now, if I've got 2 fractions multiplied into each other, I don't need to convert anything. It's basically going to be 3 times 8 divided by 4 times 9. That's basically how it happens. 3 times 8 gives me... Oh, hang on, let me just write it up first. 3 times 8 gives me...
24.
4 times 9 gives me... 36. Can that be any nicer? 6 over 9?
Yeah.
Then 3 over 1? Wait a second. Can we fix that? Yep.
2/3.
2/3. Alright, good. So can you see how multiplying 2 fractions against each other is really simple? Yep. So you want to cancel things out. I like that strategy. So let's see what she was describing just now. She said if you simplify it at this stage before you start multiplying them out, you don't have to deal with such big numbers. So I can see there's a 3 on top. That can cancel out. This 9 here is basically 3 times 3. So if I swap this out, the number 9 for 3 times 3, I can take out the 3 on the top, take away 1 3 from the bottom. See the strategy? I'll write that again in blue ink. So I got 3 times, well, since there's 8 and 4 on the bottom, I can have 2 times 4 gives me 8, doesn't it?
Yep.
And the 4 still hangs out in the bottom. And we already expanded out that 9, which we turned into 3 times 3. So now I can cancel out that 3, because it appears top and bottom. That's just one of the things you do in maths. And I can cancel this 4 on both top and bottom. So what's left remaining? All I can see in the top now is 2 and 3. I like your strategy there. That seems like a lot less work than what we were trying to do here. Okay, 2 ways of getting to the same answer. This one here, you already know the rule because I had it up here. So this question is going to be what on 3? 1 times...
27.
What?
1 times 9.
1 times 9, which gives me 9 on 3, which we simplify 3. Easy? Okay, this one here is probably going to be the hardest type of problem. It's when we got 2 mixed numbers multiplied into each other. What's the strategy that we have been applying so far when we're adding and subtracting them? What have been the strategies that have been working for us? Yeah? Pardon? Yeah, so we have partitioned the fraction bit and worked on that. Once we've fixed those up, then we started working with the whole numbers in front. What's another strategy that we've been working with to do adding and subtracting with mixed numbers? It's on the board.
Converting them to improper fractions.
Converting them to improper. I'm going to go with converting to improper as my preferred strategy. It might take longer. After I'm done, I might give your style a go where we try and see if we can figure it out just by leaving the whole numbers alone and see what happens. Alright, handwriting's atrocious. I get so nervous on camera and in front of a whiteboard in front of 30 kids. It all adds up. So I'm trying to convert the 2 and a third. So that's going to be 2 lots of 3, because that's where that 2 is worth. and add whatever's left on that numerator, which is 2 plus 1. There we go. Times by 1 lot of 5 plus the 2 that's already up there. 2 times 3 is 6 plus 1 is 7 on 3. Times by 1 times 5 is 5 plus 2, it gives me 7. Now I can just go 7 times 7 and 3 times 5. So 7 times 7, guys, is, yep, 49. 3 times 5 is 15. Can that go any nicer? I don't know. Maybe, maybe not. I was thinking 3 as well, but I'm not sure. For this bit, I'd check a calculator, but I think that might be as simple as it can go. If it can be divisible by 3, then yes, you would reduce it down, but I'm not sure. Can't be done? Alright then. That's the trick. So in summary, guys, if I've got a fraction times by a whole number, that whole number gets absorbed into the top of the fraction. So it becomes 2 times 15 over 5. Here it's 1 times 9 divided by 3. That's how it works. If you've got 2 fractions multiplied each other, basically the 2 tops get multiplied, the 2 bottoms get multiplied. If you've got mixed, then you might need to convert them into improper first. That's it, guys. Hope you got something out of the video. We're going to go and do some practice.